This lecture deals with minimization of finite automata, that is minimization of DFA. So we are actually following table filling algorithm. So let us consider this particular DFA. So you are having six states, out of which Q5 is actually unreachable. Unreachable in the sense it is not possible to identify a path from Q0, that is start state, to state Q5. So this is unreachable, and you can straightforward eliminate this particular state. You don't need to add Q5 in the minimized finite automata, because if you consider any string accepted by this automata, Q5 will never become a part of that. So in table filling algorithm, after eliminating unreachable state, you need to count the remaining number of states. You are having 1, 2, 3, 4, 5 states. So you need to construct a table of size 5 by 5 like this. So label, if you consider the column wise label, it will be Q0, Q1, Q2, Q3, Q4 in this particular order. And if you consider the row wise label, it will be from top to bottom, it will be Q0, Q1, Q2, Q3, Q4. Now, remember that you don't need to use the diagonal and the upper half. So you don't need to use the upper half and the diagonal. Now, we are having pair Q0, Q4, Q0, Q3, Q0, Q2, Q0, Q1. You are having all possible pairs of states, and for each possible pair there exists a unique cell. So you need to identify whether each pair is distinguishable or not. So whether a pair of state is distinguishable or not. So consider the pair Q, or consider the pair PQ. So PQ is said to be distinguishable if there exists at least one string X such that delta cap Px is equal to some state R, and delta cap Qx is equal to some state S, such that out of R and S, one is a final state and the other is a non-final state. In the sense, if there exists at least one string for which starting from P, consuming that string, it will lead to final state, and starting from the other state, consuming X, it will lead to non-final state. If you can identify such a string, then that pair of states is said to be distinguishable. So you need to identify all those states that are distinguishable and mark those states. That is the first step involved in table filling method. Then another important point, if I take a pair of non-final state and final state, you can straightforward say that that pair is distinguishable. For example, if you consider the pair Q0, Q3, that is distinguishable. So you can mark this as distinguishable because Q0 is a non-final state and Q3 is a final state. So all pair of final non-final states will become distinguishable. So Q0, Q4 is distinguishable. Then Q1, Q3 is distinguishable because Q1 is a non-final state and Q3 is a final state. Now Q1, Q4 is also distinguishable because Q1 is non-final, Q4 is final. Now Q2, Q3 is distinguishable. Q2, Q4 is distinguishable. So mark the pair of final, non-final states as distinguishable states. Now we need to process the pairs Q0, Q2, Q0, Q1, then Q3, Q4. You need to process, and again Q1, Q2. So first you can consider Q0, Q1. Q0, Q1 pair. So here the inputs are 0 and 1. So apply 0. So when you apply 0 to Q0, Q00 gives Q1 and Q10 gives Q2. So by applying 0 you will be getting the pair Q1 Q2. Verify whether Q1 Q2 is marked as distinguishable or not. It is not at all marked. So you can apply input 1 to Q0 Q1 pair. We are going to apply input 1. So what is Q01? Q01 is Q2. And what about Q11? Q11 is Q3. So check whether Q2 Q3 is marked as distinguishable. Q2 Q3 is marked as distinguishable. So you can say that the pair Q0 Q1 is distinguishable. So Q0 Q1 can be marked as distinguishable. Now you can consider the next pair Q0 Q2. Q0 Q2. Apply input 0. Q0 0 gives Q1. Q2 0 gives Q2. So verify whether Q1 Q2 is marked as distinguishable. Q1 Q2 is not at all marked. So you can apply input 1. So Q0 Q2 1. Q0 1 gives Q2 and Q2 1 gives Q4. Check Q2 Q4. So Q2 Q4 is marked as distinguishable. For that reason you can say that Q0 Q2 is distinguishable. So mark it as distinguishable. Now you can consider the pair Q1 Q2. Q1 Q2. Apply input 0. So to Q1 if you apply input 0 you will be getting Q2. And to Q2 if you apply input 0 you will be getting Q2. So Q2 is not a part of our table. Now you can consider Q1 Q2 1. So if you apply 1 input to Q1 it will go to Q3. And if you apply 1 input to Q2 it will go to Q4. So check whether Q3 Q4 is marked as distinguishable. Q3 Q4 is not at all marked. Now you can consider the pair Q3 Q4. Apply input 0. So Q3 0 is Q3 and Q4 0 is Q4. Now Q3 Q4 is not marked. Q3 Q4 1. So Q3 1 is Q3 and Q4 1 is Q4. So here Q3 Q4 is not marked. So after processing all possible pairs, we can see that these two pairs are not marked as distinguishable. So we can say that these two pairs are actually non-distinguishable. For that reason you can combine these two states. You can say that Q1 and Q2 are equivalent and Q3 and Q4 are equivalent. So based on this you can construct the minimal DFA equivalent to this given DFA. So you are having state Q0, that's the start state. Now Q1 and Q2 can be combined. Q1, Q2 can be combined as a single state. Now Q3, Q4 can be combined. Q3, Q4 can be combined. And it is clear that Q3 and Q4 are final states. So you can mark this state as final state. And Q0 is the start state. Now what about Q00? Q00 actually goes to Q1. So Q00 must go to that particular state containing Q1. Now what about Q01? Q01 actually goes to Q2. So Q01 must go to that particular state containing Q2. So Q001 will give Q1 Q2. Now what about Q11? Q11 is Q3. So from Q1, one transition must go to that particular state containing Q3. Now from Q1, what about 0 transition? From Q1, 0 transition goes to Q2. So from Q1, 0 transition must go to that particular state containing Q2. Now you can consider Q2 1. So Q2 1 actually goes to that particular state containing Q4, that is already here. Now Q2 0 is actually Q2 itself. So that will act as the self transition. Now if you consider Q3, what about Q3 0? Q3 0 is Q3 itself. So this transition must go to that particular state containing Q3. Similarly Q3 1 is actually Q3 itself. So that transition will remain in the same state containing Q3. The same thing happens for the state Q4. Q4 0 1 actually remains in Q4. So this self transition will act as Q4 0 1. So this is the minimized DFA, and once after obtaining this particular minimized DFA, if you want you can relabel, like you can label this as Q0 itself, you can relabel this as Q1, and you can relabel this as Q2. So if we verify this particular transition diagram, for each and every state there exists unique 0 1 transition. So this is the minimized DFA, and that's it.